Hello everyone, and welcome to this presentation called aspConfFastFasterAsync ASP.NET. I would be in chat mode, meaning that I won't listen to whatever happens in the room. I won't follow the chat either because I just want to concentrate on the presentation. So this is a presentation called aspConfFastAsync ASP.NET, and as the name implies, available today for us to make our application faster and mainly using the async functionality. So let's get started, and I will start by introducing myself. My name is Tiberiu Kovac, and I am a senior software architect with Falafel Inc. And I was awarded MVP in technical computing last year for all my contribution in the area of parallel computing and asynchronous computing. So technical computing, for those of you that doesn't know what it means exactly, it's actually the marriage between parallel computing and high performance computing. So Microsoft created this initiative a couple of years ago, and they have made this possible. They made this award technology called technical computing. I'm as well a Microsoft certified trainer. I'm a certified trainer since 2004, and in my daily job as a MCT, I'm actually training people .NET technologies, everything from the introduction to .NET to the most advanced topics that are available. I am as well an ASP insider, having a lot of good conversations with Microsoft about the future of ASP.NET. I'm a Telerik MVP and insider. I'm a geek, and I am proud to announce it. And if you want to follow me on Twitter, I am Tibor19, and the hashtag for this conference is called aspconf. So if you want to tweet about it, you can include my name, you can include the hashtag of the conference. So let's see what agenda do we have for today. It is a very short one, and my idea was to keep it very simple, and we will start by looking at the ASP.NET page lifecycle. And the reason I want us to look at that is because most of the people think they know it, they might know it, but they might have forgotten it as well. So I just want to have it as a refresher, and later on we will see how this one actually fit nicely into the async world of ASP.NET applications. I will show you how to load test your application. The reason I want to show you that is because I really want you to understand what's happening with your application in production, or at least how can you do that if you want to better understand what's happening with your application in production, and as well to find some potential bugs or some potential scalability problems that you might have with your application and you might not be aware of just because you don't see them in your staging, you don't see them in your debugging machine. They mainly surface only when you run your application in production. I will go then and show you how you can work with asynchronous pages, and those are actually the asynchronous pages I will show you are mainly done for the previous versions of ASP.NET up to 4.0. So maybe you notice that I called the ASP.NET 4.0 the previous version because Microsoft has the 4.5 as a release candidate, and during this summer maybe we will soon we'll get the in the fall we'll get the new version of the Visual Studio. And if you work with if you are one of the lucky ones working with that, actually you might even be able to use the async support that C# will bring with it. And if the time permits, I would look a little bit at the asynchronous actions as well. How can you do asynchrony for your MVC applications? So enough for the agenda and the introduction, and just let's get started. So the ASP.NET page lifecycle, it's pretty straightforward. You have the init phase of the page, and when you init the page, normally you have a pre-init where you can change the master page, you can change the theme of the page. Then after that will come the init itself, and when init is done, then you'll have init complete. Then you have load, and load has preload, where it means that you can actually start the start some loading of the data. Then it's the load itself that will recursively call the load on all the controls you have on the page, and then load completed on the page itself to mark just the fact that all the loading in all the controls has completed. Next step is pre-render. On the pre-render, it means that, you know what, now I gathered all the data that I need on the page itself, and now I need to make sure that if I need to do some final touch, some final changes, there is a place where I can do them. After the pre-render comes pre-render complete, and pre-render complete is the absolute last place that you can do any changes to the structure of your page or the content of your page. After that, the render method will be called, and render method will start sending HTML to the client application, or Internet Explorer in that case. As soon as you start doing that, because TCP/IP because the TCP/IP used it does not offer the possibility to get back the information you already sent, you won't have any possibility to change the structure of the data. So again, pre-render complete, it's the very last place that you might do any changes in your application. And with that said, I will actually make a point a little bit later why it's important and why did I show both pre-render and pre-render complete. And after pre-render complete, you will have actually the unload phase of the page and the disposal of the page, of course. So unload, if you did allocate anything in the load phase of your page, you would actually deallocate or remove or dispose in the unload. If you did something in init, normally you would do it in dispose. Both of them, they can actually, you can do the disposal in both of them, but just if you want to keep it, you know, clean, you would do it with load, unload, and init dispose as counterparts. So let's see what we will look at today. I have a small application. The application is actually pretty simple. Let me open the correct one, which is this one. So in my application, what I'm doing actually here, I can just show you how it looks like. I'll start Internet Explorer and I will show you what the application does. It just goes to the, it's a simple application where I have recipes for different kind of food. And amongst other, I have an I Feel Lucky page, and I Feel Lucky page will go and just do a randomization between 1 and 10. I have only 10 recipes in my database, so it's a very small one. But what I'm doing actually is I'm looking at I'm reading a recipe, and then I print out the method that I'm using for retrieving the data. This is a synchronous method, and I'm looking at the execution time, how long it took me to render the page. So 3 seconds might feel okay, you know, I mean 3 seconds is still under the limit of people getting bored, and it might happen, you know, I mean if you blink a couple of times, then 3 seconds will just be gone. So it's not such a big issue if we do it this way. But as it happened, I got some reports from, you know, my auntie that she wants to use my page and she wants to use my application to find some of the recipes available, and she just told me, you know what, I don't like the way it works, it's just too slow. So what's happening? And I'm trying a couple of times. I'm doing some refresh. I've asked her which recipe it was, and it's still the same problem. So it's roughly above 3 seconds. So let me go here, and I will show you the code pretty quick. I start a stopwatch when I start the loading of the page. The reason for doing that is just because I want to see how long it will take from the time I'm starting to load the data in the page until the point that I'm actually done with it and try to send it to the client. And then I have an error in case that something is wrong. I want to display some error as well. And then I have 3 different methods that are actually retrieving 3 pieces of information about my recipe. I have some details about the recipe, like the name of it and the price and stuff like that. I have the ingredients that I need for the recipe, and I have the instructions that I need for the recipe. And as well, I will display the method name used to retrieve the data. The implementation is straightforward. It's an ADO.NET. I don't have to go through Entity Framework or Hibernate or anything else. I just wanted to keep it pretty simple. I'm reading the DB connection string, and with that I will go actually and read the recipe, run the get recipe details stored procedure from the database. And with that I do an execute reader, and with execute reader I will get actually the information from the database, and when I'm done I'm closing the connection. Get ingredients does exactly the same thing, so there is nothing different, just that it has instead of having one record, it has a list of records. I can have many ingredients, so instead of reading that and put it in some controls, the only thing I'll do now is I'm just reading I'm just putting the data bind. I'm calling the data bind method. And then the last but not least is the get instruction method. Get instruction does exactly the same like get ingredients. So application is pretty straightforward. We want to make sure that we do the right thing, so let's do like this. We can try it in the solution in Visual Studio Ultimate Edition. I always get this question, which of the versions does it use this? In the Ultimate Edition we have the possibility to create different kind of tests for our solution. So the two kind of tests that are actually very useful are web test and load test. Web test does nothing but just goes to a page and records whatever happens. It looks at the data you are sending back and what data you are sending to the server, and then what data you are getting back, and records that, so you can do actually a replay of the information. So what I have here, for instance, I have the fast load web test, and the fast load web test, let me change the address here actually to the correct one. So the fast load web test here, it just goes to the page, to the address called 15001 on the local host, and it opens the default page. So if I try to play this one, I will press here run test. It will go to this particular page and it will just show me the request, and it will show me the response as well. I can look at the header send, I can look at all the information, so I can get a lot of information about my application. I can even put some time that I would prefer to get the answer within. So if I don't get the answer, then this one would be actually marked as an error. So if you do some continuous integration, you can have even web tests run in your application to make sure that the stuff you are doing are correctly set up. So this is the fast load. I have another similar one created for the random recipe. So if I go here in the Solution Explorer, I will look at the random recipe load web test. Let me change that to 15001. This is the port I'm using for this particular application. And again, if I'm running that, it will show me what's happening with my particular application. So I'm going to random recipe. Random recipe will go to do a redirect to display recipe, and then the result is that. And the request time is actually, as you can see here, it's 3.022 seconds. So that's how long it takes me for this application to run. With this web test now, I can go in the Solution Explorer here and create actually a load test. As it happened, I have one already done, but let me show you how you create a load test. Unit test settings, where is it? Here, let me do like this. Add a load test. So when you start load testing, you will be asked for a scenario. What do you want to actually for this one to be called? And if you choose a meaningful name, you will know exactly what the scenario was, what you were trying to achieve when you were load testing your application. How do you want, if your application needs to do think times, like, you know, a normal user won't just click. It does a click and then it waits for 5-10 seconds, sees the next link, and then another 5-10 seconds, and so on and so on. If we want to do that or not, I will just use normal distribution. So I don't really want to go into details for that. That's not the point of the presentation. Anyway, user counts. You can have as many users as you want. But by default, only 250 users are allowed for this application to be loaded with. If you want more, you would actually have to unlock a feature on your Visual Studio. I'm not sure if the new version of Visual Studio, the one coming, the 2012 will have by default all of them enabled, or you still have to install the feature in your application. But I would say I need 250 users. If you think about it, 250 users is not a big number anyway. How do you want to mix your tests? Either based on the number of tests, or if you want to have based on the number of user, or how, you know, different user might have different think times and stuff like that. Again, just take the default here. And which one of the tests I want to run? I want to run both fast load and random recipe, meaning that some people will come and go directly to fast load, other people might go to random recipe, and so on. When you create your web test, by the way, you don't have to go only to one page. You can actually have a whole range of pages that you are going through, so you can simulate a whole range of actions in your application. So I chose those two. I want them 50-50 distributed. If I want to choose the network type, I can have my grandmother calling with her 56K modem, or I can use a 3G, or I can use whatever kind of network I want, because I want to see my application, how does it behave on different kind of scenarios. Again, I leave it like this. Browser mix, if everyone would run Internet Explorer 9, 10, 11, or 5.5, or whatever Internet Explorer you would want, because you want to catch this kind of functionality as well. And then if you want to catch some of the counters, by default you will get the processor, you'll get some other functionality as well. So then I say, how much do I want to run it? I can say I want to run it for 10 minutes. If I do that, it will mean that we will lose a lot of time, but by just doing that. If I want a warm-up duration, you can have everything from 0 in a normal application till hours if you run SharePoint. So you need your warm-up there. And I'll press finish here, and when this is done, I will have a load test 1 here, and I can actually run it and see what's happening. So if I press run here, it will start my application. Let's see. And when it starts the application, it will start to take some timing and look at what's happening with my my different pages. And let me close those. And what's the average response time of every application, or on every page? Let me see if I have the site up and running. It should be here. No, it's not. So this one is not working right now. I will have to open the solution and say I want to see this random recipe in the browser. If I see it in the browser, it will start automatically the Cassini. So by having Cassini started, then it means that my application it's up and running. Let me see, localhost 15001, of course, HTTP dash like this. Yes, so now it's up and running. Again, it looks like this. So let's remove it so it's not staying in our faces, and let's try to run it again. This time, because the site is running, we will actually measure some of the some of the counters. Anyway, so as you can see up here, we have the warming up period. It's 7, 6, 5 seconds, and the reason we want to have some warming up is because I just don't want this time to influence the way my application is run, and I want to make sure that it's run correctly. But as you can see, my application already now it's very heavy loaded. My response time, it's like 9 seconds, and 9 seconds it's for, let me change a little bit the way it's showed. I will show only one panel, and I will show the page response time. And the red one is my default page, meaning that this one shouldn't take more than a couple of milliseconds, but it still takes between 0.97 to 10.3 seconds. And I have the random recipe that I know it takes 3 seconds. I've seen that because I measured that. But if I'm looking at it, I can see that it takes a very, very long time. So let me go back here and look at the random recipe and see how long it will take in this situation, for instance, while I'm doing the load testing. So right now I'm starting to feel the pain my auntie is feeling because it takes a long time to show it. So, but actually this one still answered pretty quickly. But if we look at the results of this one, if we look at the graphs of the results, we can see that we have a very high response time in our application. And we have times between 11 seconds up to 17 seconds with an average of 15.5 seconds. And we have 7.64 to 10.03 to an average of 8.50. So, a rhetoric question, I would answer it for you, is why do you think this happens? So think about it for like 10 seconds and see if you can figure out why this would happen in your case. Okay. So 10 seconds are gone. Now I can tell you why that happened. Every single request, when it's actually served to the ASP.NET application or by the ASP.NET, it would be allocated a thread. There is a request thread pool specially for that. So every request will get a thread, and then it will actually go through all the lifecycle stuff that I showed you a little bit earlier. And while you do that with your with the application, it means that there will be less one thread in the pool. The pool is by default configured with 20 threads per core you have in your machine. So in my case, I have a dual core machine, and the result is that I get like 40 threads. Having 250 users, it means that I have a lot of users concurrently going and accessing my page, but only 40 of them will be able to be served. Why? Because for the 3 seconds period, I will always, I have a lot of other all the threads busy. So as soon as the 3 seconds are gone, one user will leave the thread back, and then the next one will be served, and so on and so on and so on. Of course, you might think, but why not leaving the thread pool alone and then create your own thread? Yes, that might be a solution, but Microsoft's recommendation is that you would never create threads in ASP.NET applications. Why is that? Because if you have 1 million users and 1 million users will allocate 1 million threads for that, you would be in big trouble. What you might want to do actually is to asynchronize your application. What I did beforehand, because this one, I might get some comments from people like, but don't you run the application, the database and everything on the same machine, and that's why it's slow, and it's not because you have a lot of load? Well, let me show you how it looks actually on my server at home. I have a dual quad-core machine, so 2 processors, quad-core, and I will show you what the results are in this case. When I'm doing the sync load, so from now on, instead of going and show you going and running this and waiting for 1 minute and 15 seconds, I will just show you what the results would look like on my server without having the need to go there. So if you see here, the page response time, it's pretty big too. And just proving my point actually, let's do one panel and let's take the page response time. And you will see that even though I have 8 cores on my machine, that I will actually have 160 threads, I still get response times of about 2 seconds and 40 for the default page, and 6.53 for the random recipe page, the one that is not working correctly. Now, the reason it takes a long time, it's pretty simple. It's because I'm running 3 store procedures, and every store procedure, when I call it, I'm actually starting on the SQL server the call with wait for 1 second. Why I do that? I want to simulate some load on my SQL server as well. So when my application is running, You know, I have a complex query, or I have 2-3 complex queries, and they take a lot of time. So for me, it would be pretty interesting to see exactly how they will look in a let's call it a real life situation. So that's why I did it this way. So if I have 3 queries now, every one of them waiting for 1 second before starts to run, of course that the end result would be that I have to wait for 3 seconds before my page it's run. So how do we solve this kind of problem? Of course, because there are 3 different queries, we can say, but you can run them in parallel. Yes, that's true, but how do you do that? You would have to run something like threads. Let's not think about how .NET 4.5 it's working. So let's just do it, you know, let's just do it with the ASP.NET. Let's talk about ASP.NET 4. So what we can do instead, use the asynchronous capabilities of the .NET Framework 2.0 and upward. So the capability of those would be the capability. The reason you would want to use that are as follows. So let's look. Why do you want to? Let's look at the difference between synchronous and asynchronous. First of all, when you do synchronous, you have a method, you call it, and you wait for the result. This is a very good thing because you have one method at a time, and it's very easy to program and very easy to understand. I mark this as orange, red, whatever, you know. I just want to mark that this, although might seem as a good thing, sometimes actually, especially when you have long-running I/O operations, it's not such a good thing, because if you call the method and you wait for the result for 1 second, I can't do anything else. The thread will just sit there and wait patiently for you to return the result. Again, calling one method at a time. You know, the longer the wait it is, for every method, the longer the amount of time would be. But for us, it's very easy to follow the program. We can just say, okay, this method is called, and then we get the result, and then the next method is called, and then we get the result, and then the next method is called, and so on, and so on, and so on. With a synchronous method, you would have to, you will call the method. That's how you normally do it. And after you call the method, you will get the result right away. Then the result or the method completion information, it's done via callback. So I need from the caller side to say to my method, say, whenever you are done, just please inform me. And we can do it in different way. The most common way is actually to do it via callback. So if you do it via callback, your method would get called when everything is done. Another possibility would be just to wait for it, you know, so you can start several asynchronous methods at the same time, and then you wait for all of them, and you would wait for the longest period of time that your methods will run, but you'll not wait for all of them at the same time. You'll wait for them in parallel. The biggest advantage would be exactly this one. You can run several methods in parallel.
Hey, Tibby.
What does it bring you?
Yourself,
it will bring you scalability. And because you have scalability, you can have actually several requests served by your application without having the need to wait for this for this to happen. But there is one point here. It's harder to program. It's much harder to understand. It's much more harder for us as developers to follow the application and how the application itself works. So I will show you in a minute exactly how does it work. But before I do that, I just want to tell you how asynchrony is implemented in .NET Framework before .NET Framework 4.5. So I will take as an example the event handler delegate. The event handler, or all the delegates, when you create a delegate, you just specify the name of the delegate. So for instance, if I want to, event handler is defined in the system namespace and is defined as a delegate void event handler, and it takes 2 parameters, one of the type object
Tibby?
and the other type event
Tibby,
arg.
if you can hear me,
What it means that all the methods that have this particular signature,
live meeting
no return
interface,
and send object and event types as parameters, can be called event handlers. So a very typical event handler, it's page load. another one is page init, and so on and so forth. All of the page events that we have actually all of them are defined as event handler, and Microsoft chose event handler as the starting point for implementing asynchrony in ASP.NET as well. When you define a variable of the type event handler, you will get three methods. So whenever you have a variable of this type event handler, that variable will present those three methods. One called invoke, that takes the two parameters and would return void, so it will function exactly like you would invoke the method itself. The other one called begin invoke, that has the same parameters as invoke but adds two extra parameters, one called the async callback and the fourth one called state, so I can pass state back and forth in my application. The method will return the async result. Async result, you can wait on it, or you can just ignore it when you call the method, especially if you send the callback. And when you send the callback, in the callback itself, you would call end invoke. And end invoke take the same async result as parameter as we have up here. So resume your presentation. Enough talking. Let's see how this actually changes the way we program our application. I told you at the beginning that the page lifecycle actually has, or the point between pre-render and pre-render complete has a point. So if you remember the picture from the beginning, when you run an async page or an async application, what would happen is that between pre-render and pre-render complete, all the async calls will run. So that's what Microsoft will take care of. So we don't have to do that. Pre-render complete is actually an indication that whatever you started, asynchronous on load or init or whatever you started, you would have to go back. So cut back in. So let's continue. Let's go back to our application and see how does this apply to whatever we are doing right now. So I can go into the display recipe and I will try to make this page asynchronous. There are several things that we will need to do in order for this page to be an asynchronous page. The first one would be to go to the page itself. Let me see, let's do like this. Go to the page itself in the aspx and add an information telling that the page is asynchronous. So the page definition at the end here, I can specify that the page is asynchronous. Without that, whatever I'm doing now will not work. So if I put async equals true, and when I'm running my application, if I put async false and I'm running my asynchronous page, then ASP.NET will throw an exception telling me that you cannot call asynchronous method in a non-asynchronous page. So that's the first thing I will have to do. Asynchronous timeout is just to tell to ASP.NET how long do I want to wait for an asynchronous call to complete before it will generate a timeout. The next thing I would need to do is to change the connection string. The connection string I am using to the database, it has to include asynchronous processing equals true. If I'm not doing that, the problem I would have when I'm running the application would be that the connection pooling will not work correctly, and I will get SQL exceptions telling me that you open the connection in one thread and you try to call it in another thread. So that's the second thing. And then the third thing is just to go into my application and change the code I'm running. I will still keep the functionality as it is, but what I will need to do is to use a method available from ASP.NET 2.0 called add on pre-render complete async. This method takes two parameters, one called begin event handler and the other one called end event handler. Those are actually two pair methods that you can use in order for you to call asynchronous your application. So let me see how can we do that. We can just go here, for instance, and my begin event handler will be pretty simple. I would have begin event handler. If I look at the definition, it's a method that requires 4 parameters, like I showed you a little bit earlier, and it returns an async result. So let's try to do that. How do I do that? I would say I will use a lambda expression, and the reason I'm using a lambda expression is because I want to keep the code as compact as possible. Having the code compact will be much easier both for me and for whomever else will look at my code to follow the logic in the application. So although the method is asynchronous and is not happening, call 1, call 2, call 3, it will still be easier to follow for some for anyone following my code. So the first parameter I will call sender. The second parameter I will call event args, because it's the event args, or I could even call E, like it's accustomed. The third parameter would be the callback CB, and the fourth parameter would be the state that I want to send. And of course, this method has to return an async result. Well, where do I get the async result from? The easiest way for me would be to take the async result by using this, by using the functionality already available in the SQL data reader. So for instance, I will go here and I would say that instead of calling the execute reader, I would like to call the begin execute reader. So Microsoft, when they started working with ASP.NET 2.0, actually from the 1.0 version already, they introduced some asynchronous methods. And they are implemented asynchronous at the operating system level, so it's not something that we need to force and make it asynchronous. Being done this way, it means that we'll use the possibilities that you have in the operating system. So if we look at this method has several overloads. Amongst them has one that takes a callback and the state. So because I want the callback and the state to be passed from the ASP.NET onto the end invoke method, I would have to send them as parameters here. Now the second parameter to add on pre-render complete, it's the end event handler. The end event handler, it's a void method that takes one parameter of type AR. So my AR would be a sync result. AR would be my parameter, and of course it's a lambda expression or lambda method now, and I would use all the code in here, and I will do it like I will do it like this, and then I will close this parenthesis and put it like that. Now let me fix a little bit the code. So what am I doing with the asynchronous result that I'm getting as a parameter into this end method? I would do something like command.end execute reader, and end execute reader would actually retrieve now the reader itself, the one that was generated when I called that would be generated when I called begin execute reader, and it takes as a parameter this asynchronous result. And this is the kind of handshake that you would expect from your application. So let's format it a little bit, and then let's try to look again at the code. So what we got here now, it's add-on pre-render complete async, and this actually calls the begin execute reader, and then the end method, the end event handler that takes the asynchronous the async result parameter, and that async result is sent to the end method to be able to complete the asynchronous call. And then I'm doing the reader.read and then close of the method, and so on and so on and so on. I'll need to do that for all three methods that I have, but what I'll do instead, I would actually go and show you the ready-made code. So let's go back here and let's see, I have the add-on pre-render async complete, I have the sender, the event tags, the callback, the state. So exactly like before. I have the next one here, the get ingredients, that has exactly the same signature, and then I have the get instruction that does exactly the same thing. So let's start running the application again. and this is it. Okay, so it took 3 seconds and 3.232 seconds. So that's not actually an improvement. Let's try again, and we will see that we get almost the same kind of value, 3.008. So what's the reason for that? And why would we do that if you don't get any improvements? Let me show you what happened actually when you do the testing. If we look at the manage results, and we take, instead of the sync load, we take the add-on pre-render complete. Let's open these results here. And we can see that the response time improved very, very much in our application. So let's do one panel. Let's take the page response time, and you can see that actually you have a flat line at 3.1 seconds for the random recipe page, and you have zero, almost 0.032 for my first page, which means that we get a lot of improvement in the performance of our application. The reason for that is because using the asynchronous functionality, we'll actually release the request thread as soon as we are on the pre-render method. And then in the async calls that were happening on the side, we will call all those, using separate threads or separate threads from the thread pool or IO completion ports or different technologies anyway to complete the calls that we have to make. And then when those are ready, they will come back, and pre-render complete will wait for another request thread to be available to just pick up the response and send it back to the client. But there is one caveat with using this kind of solution, and that's that all the asynchronous operations have to be run sequentially. That's one thing that Microsoft, I don't know why they choose to do it this way, but that's how it works. So if I want to run them in parallel, I'll need to use something different. So what can we use for that? Well, we can go here and we can, let's take back this one, and instead of using the, like it is here, instead of using add-on pre-render complete, we can use something that's called page task. So the page task, there is a method called register, let's see, page async task dot, that's then the class name, register async task, that's the name of the method, and we register a new page async task. The new page async task, the constructor of this class takes actually several parameters, but the first two of them are begin event handler and end event handler. There is an extra parameter called event handler, end event handler, but for the timeout. So in case that you get a timeout and you want to notify the user about that, you can actually send your own event handler. So async timeout that I showed you a little bit earlier on the aspX side, it's when this one gets used. Then you have to send some state if you want to, and then there is another overload that's called bool execute in parallel, meaning that if you set that to true, all the async tasks that are marked like that can be run in parallel. The reason you want to do that is because you know that those are completely independent of each other, so you don't care if they are run in parallel or if they are run sequential. The only thing that would decide that would be the amount of cores or the amount of resources you have on your machine, not the way you are writing your code. I'm not interested on the event handler timeout, so this will be null. I'm not interested on the state, this would be null as well. But this would be, the last one would be true, meaning that I want this one to be run in parallel. And let's close the constructors parentheses, and then this is the register async task method parentheses. So now we change the code, and it's pretty straightforward. So let me save that, and instead of going and changing all three of them, I would go to the ready-made solution. It's the same thing for all three of the methods, register async task, register async task. By the way, this is a method of the page, it's not a method of the control, so you have to do it on the page, at the page level. So if we run the application now, we will see that we'll open a new port 15003, and if you run the random recipe, the result is 1.1 second, which is more or less what we want. We have 3 different calls to the database, and all 3 of them they happen within 1 second. So that's what you would expect anyway from your application. So everything looks very good, but we need to see how the load results are looking. So let me open the manage results again and go to the page async task. At the page async task level, if we go and choose again one panel and then we choose the page response time, we will see that we have actually 1.47, the average time for this one, and we have 0.33 for the main page. What we get actually, it's not that we get the worst response time for the default page, is that we get more throughput. So that's why we get a little bit higher than before average time for the default page. But we get a very good response time for our random recipe page, or actually display recipe page. Another thing that will happen here, it's the fact that you have you have 2 spikes here. And I scratched my head a little bit and I didn't understand what happening, but what happened at the end, actually, when I looked at the counters, I discovered that actually in this point my processor was actually fully loaded. Of course, this is the nightmare of your IT pro guy, because he would not like the idea of not doing anything. So you know, and that you have a machine that is 100% loaded. But actually, in our particular case, this meant that we were actually using the resources in a very very good manner. So this is the way you would do it actually when you run your application together with the when you run with the page async task. But this one, if you look at it, it's pretty cumbersome. The code itself, I mean, even though it's easier to follow, let me put it this way, it still requires a lot of boilerplate, a lot of stuff that you need to add around, a lot of stuff that you need to make it working. And maybe that's not the way you want to do it. So how can we solve that? How can we make that into a more sustainable solution? So let me go back to my Solution Explorer actually here and just do an undo pending changes, meaning that whatever I changed, I just want to take it back. So I will start with my clean page, you know, the way I've done it before with the get details. And what I will try to do now is to use the new features available in C# to make it work. So let me show you why I want to do that. And we go to this. Let's open the presentation and let's look at the C# version next. What Microsoft did with the C# version 4.5, as it is called right now, they actually add support for asynchronous programming. Their effort was called actually asynchrony for the masses, meaning that everyone should be able to use asynchronous programming, and the code shouldn't be that cumbersome and shouldn't have those many problems like we saw a bit earlier. So they make it look more or less like synchronous programming. And how they did that, they used task and task of T behind the curtains, and they added 2 new contextual keywords. What does it mean, contextual keyword? A contextual keyword is actually one that has a meaning only if it's in a certain place. So for instance, we have a new keyword called async. For this one to be treated as a keyword, it has to be right after, it has to be before the return type of the method. So if I have a method called void, and if I have a void method, and if I want to make it asynchronous, I'll have to write something like async void. So that would mark my method as asynchronous. And then they have another one called await. Await will yield control actually from the current thread to the caller. So the caller will go back and he can do something more asynchronous, and when it gets the result, we'll actually try to do a context synchronization and get back to the same place where it was before and continue and deliver the response. More or less what we did, but in a much cleaner way. So let's look let's look at how can we modernize our application. If we start from the beginning, again, as I said, we will go to our first method. It's called void get details. So what I have to do first is to say async. So now I mark this method as async. As soon as I mark the method as async, I'll get a squiggly warning here telling me that, you know what, you have a method called you have an async method here, but this method does not have any await operator in it, meaning that I won't be able to run it asynchronous anyway. So even though you put it, it will be a synchronous method. Now it will be one synchronous method, it will not be one asynchronous method. So let me make this distinction clear. The second thing you'll have to do, it's either change void to something else like task, or leave it as void. You would want to change it to task if you want to be able to wait on it. So I would say, you know what, if this get details, I want to synchronize the code up here, then I would add it as a task. Otherwise I can just leave it void, and then I don't have any problem with the way it's run. Next step would be to change the name of the method. It's not obligatory, but it's a recommendation from Microsoft that all the asynchronous methods should have the async suffix in their name. By doing that, you indicate to the caller that, you know what, this method is an asynchronous method, and you might have some, you might actually have some benefit of using that. Next step would be to add the await part. So await, of course, requires that you have something that is awaitable, a task or whatever awaitable you are creating, or an awaitable object in that implementation. So now we get a bit of an error telling us that execute reader actually it's not something that you can await on, because it's returning void and it doesn't know how to do that. But Microsoft went ahead and created a lot of extension methods to the most common methods, asynchronous methods that we already had in place. Like execute reader, because can be called asynchronous as well, Microsoft created an extension method called execute reader async. The method is defined actually as a task of SQL data reader. What await will do, it actually yield the control from here, and when everything gets done, it will unpack from this task returned by the execute reader, it will unpack the reader itself and will retrieve it to this SQL data reader object. The rest of the code remained the same, including if we ever had some return values, remained the same. I don't have to return anything because I marked the method as async. The compiler will rewrite my method, and it will make sure that it returns actually a task out of it. If my method would have returned, for instance, an int, let's put it this way, an int here, then you must mark the method as task of int in order for you to make it asynchronous. So it doesn't, you can't just leave it async and hope that it will work. But in our case, this method is void, so let's remove the int from here. So I don't have to have an async of int. The method would be changed to async as well. Let me actually change the name up there too. And I'll do exactly the same thing here, await, and then execute reader async. And then next step would be to go here and set await, no, async, sorry, task. So let's go back and change it, async task async, and change the name. By the way, as I told you, await, it's not blue. If you can see it, it's still black because it's not considered as a keyword, being a contextual keyword. So if I go back and change it to async, it's working. If I define a variable called async in here, it won't be any problem. So if you have existing code where you choose to name your variables as async, first I would recommend you change it to something else. But if you don't have the possibility, or if you don't want to go through all the pain of that, you can still call it async, because it can't possibly come before the name of the return type. Again, this method does not have an await. Let's put the await here, and then let's go and say get command execute reader async. If we go back here, now let's do get details async as well on this one. Now what we will have to do is to work with these methods as asynchronous methods. In order for us to do that, we need to mark this method as an asynchronous method, and then we need to put an await on that. Await, of course, and await. So let's run the application now and see what's happening. So if we do that, we are still on the 15001, it doesn't matter. So if I go here, display random recipe, we will see that it takes 3 seconds. So again, the same problem that we had before. And the reason for that, of course, is that we are running everything synchronously. So let me go back here and show you what's happening actually behind the curtains. If we go and look at the test and look at the managed results, we will see that the async await, when you run it, it will have the flat line like we had for page add-on pre-render async complete, and we have exactly almost the same values up here. So this is not the way to do it, or at least in the case that you want those to be run in parallel. So the way to solve that, instead of having this, we will do something like var t1 equals, and then we define 3 different variables. Of course, all those 3 variables will be of type task, as we saw earlier, as we defined it earlier. So we can use the return type. And now we need to do something like await t1, await t2, or await t3, which is not really very nice. What we can do instead is say task dot when all, and then it takes a task parameter array of tasks. So I can say t1, t2, t3. So that would actually create another task, and then this task would be the one to be signaled as complete when everything gets done. So I would say await on this task when all. So if I run the application now again, I would see that now it takes less than 1 second for me to this one. So it's exactly 1 second, 1.001, 1.004, and so on and so on. So we get a pretty good time. And if we go back to the load recipe and we look at the managed results here, we can take the correct one now. So the correct version of async await here. You can see that you get a lot of more spikes because we are actually loading the application much more, and we get a lot of good results from here. Okay, we still have around 15 minutes. That means it won't be enough for me to show you the whole demo of the MVC applications. But a lot of people are actually using the MVC applications as it is right now. So let me show you how you would go and do it in the MVC 3 and how you will go and do it in MVC 4 for your application. So I'm just opening 2 new instances of Visual Studio. Let's close some older ones, like this one, like this one, this one, this one, and this one. So let's go back here. Yes. So yeah, that's the correct one. Let's go back here and let's look at our Solution Explorer, and let's open a controller and our recipe controller. Yes. So what we have here, we have our MVC application. The MVC application had an action called actually display recipe, and this one I wanted to make it asynchronous. So what I had to do was to change the name of the action from display recipe to display recipe async, and then add another method called display recipe completed. This is something that is actually done by the fact that we have now a sync controller. So if you add in MVC3, if you want to do asynchronous controllers, you would have to derive your recipe controller from, or whatever controller you have, from the async controller class, and whatever action you want to make it asynchronous, again, you have to change from display recipe to display recipe async. The method should be void, and the result, you would get it from the completed method. So the completed method would return your previous result. In my case, it's an action result, but if you had another kind of result, you can just return it from there. Then what I have to do is to tell to the base class how many asynchronous operations I'm doing. So I would have something like outstanding async manager. It's an intrinsic property on your controller that you can use, and it has another property called outstanding operation. Outstanding operations has some methods like increment and decrement, and I will say increment 3. By doing that, I would have a incremental. I will mark this as, you know, three different asynchronous operations that will be run by my application, and then I will call get details, get instruction, and get ingredients. What I have to do, if you remember, I will have to go and do the begin execute reader and then the execute reader stuff that I did before, because I want to make them asynchronous. And what I can do more here is actually use the async manager again, that's part of the page, and put some parameters. So for instance, I want to fill the parameter called details with the result of the get details method. So then the details will come actually here in this recipe details method. After I'm done with that, I will decrement the outstanding operations, explaining to my application that, you know what, right now I have only 2 left, and then next one would say 1 left, and then the next one would say none left. When you reach 0 on outstanding operations, the parameters would be composed and would be actually sent to this method here, display recipe completed. And because I sent the information as data here, I can just print it on my screen in an asynchronous fashion. Let me see if it's working, because it was just complaining about some stuff. Infrastructure optimization. Oh, okay. So I don't think I'll be able to run this this demo, but what I can do, I can show you how you can do it actually in .NET 4.5. Anyway, the result would be exactly the same as we saw in the web form application. So here what we have instead now, we can just go and have our class called inheriting form controller, so I don't need to use async controller, and instead of having display recipe, I would return task of something as I did before, and I can even mark the method as async. By doing that, I have no problem then, you know, by just doing exactly as I did before, or I can make all my methods asynchronous, because then it's much easier to call them and it's much easier to return data back to the caller, and I will return it again from an async method. So everything is actually now awaitable, and I have a lot of asynchrony that would happen in my application. So when let me see if it's possible to run this demo. No, I don't have the infrastructure and I don't have the optimization, so I did some changes in my configuration on that machine which I shouldn't have. But anyway, the end result would be that we will actually gain exactly the same benefit like we did with applying tasks and asynchrony in our web form application. The difference being here that MVC4 it's directly made aware of that, so you don't have to go and do a lot of changes. Just mark your action as an asynchronous with the async keyword and then the name of it. You don't have to change the name of the action or whatever. You just have to make that as an asynchronous method. And by doing that, you would get this kind of functionality. So, with that being said, we came to the end of my presentation. So I have shown you actually the ASP.NET page lifecycle. I show you how you can load test your application, and then I showed you how you can work with asynchronous pages, and then I showed you asynchronous support in the next version of C#, and we had actually time with some asynchronous actions. So let me see, I got some questions here. If Oracle supports asynchronous methods, I am not aware of them not supporting asynchronous methods, and the reason I say that is because I think they're doing it. They do it quite a pretty. They use actually the begin reader and end reader. So why not? I think they will use that anyway. I don't know which version do you need for that. Another question I got: how you determine which part of the application it's the one that makes everything very slow? So one thing that actually I would use in my that I would do in my application is to do some profiling. When you profile your application, you would see exactly what parts of the application are taking longer than normal. And when you know that, you know exactly what to expect or what not to, and when to look for the problems. In my particular case, I give you that I already know where the problem was because I created the problem and I added the problem there. So that's how you decide which one of the application is actually the one failing or the one creating problems for you.